Alright, so back up. 4.3 rotations. Our center of rotation is the point that we rotate around. Most of the time it will be our origin. Okay? There is one problem on your homework where it is not the origin. I'm not going to show you how to do that today because it's not on your quiz tomorrow. But after your quiz tomorrow, we'll go back and do one similar to that. But I still want you to try that problem. Okay, see if you can figure that out. But most of the time it will be the origin. When they talk about the angle of rotation, what is the angle of rotation? What are they talking about there?
90 degrees,
90 degrees, 120, 180, 270. It's how many degrees you're rotating, right? Okay. Most of the time, ours are going to be 90, 180, or 270. Okay, because that's easy on a coordinate plane. They're not going to throw like a 43.5 degrees at you. Okay, so be aware of that. Now, increments of 90 are the easiest because on a coordinate plane, every 90 degrees takes me to another axis, correct? So if I'm on the x-axis, 90 degrees takes me to the y-axis. Another 90 takes me back to the x, and another 90 takes me back to the y, and so on, right? Okay. So if I had a point here, and I rotated it 90 degrees counterclockwise, it would end up over in this quadrant, right?
Mm-hmm.
Okay. What quadrant is this?
No, 1.
1, and this is
2,
2, and this is
3,
and this is
4.
Okay. Notice when we numbered those, we numbered them in a counterclockwise manner, right? Okay. This is 2. Okay, we numbered them in a counterclockwise manner. So if they tell you to rotate something 90 degrees, but don't tell you which direction to go, assume counterclockwise. Does that make sense? If they don't give you a specific direction, go counterclockwise. Now obviously if they specifically say rotate 90 degrees clockwise, then you need to go clockwise, right? Okay, but if they don't tell you a direction, we go counterclockwise because that's the order that the quadrants go in. Okay? So, if I had this triangle up here then, and they wanted us to rotate it 90 degrees, point A is going to end up in which quadrant?
1.
1. Point C
3.
is going to end up in 3. Point B
2.
is going to end up in 2. Okay, does that make sense to everybody?
Yes.
Now if I did 180 degrees, you'd have to do that twice, right? Okay, and 270 would be 3 times. Okay. Now we did in our explorations last Thursday, which has been a while, they wanted you to come up with a rule. Okay, the rule we should have came up with is that if I start with a coordinate point x, y, and I translate it 90 degrees counterclockwise, my new point is going to be at negative yx. Okay? Meaning, from my original point, I need to flip my numbers and change the sign on the front number. Okay? So they're telling me that since A is at 1, negative 4, I need to flip these. So I have negative 4, 1, and then switch the sign to a positive 4. So they're telling me that A prime should be at 4, 1. Does that at least match up with what we know that it should have went to quadrant 1? Okay. For point B, it's currently at 5, 3. What would my new coordinate be then? Negative 3, 5. And Casey just went ahead and put that negative with it right away. Some of us might have flipped it first and then done the negative. Okay, so B prime should be at negative 3, 5. And C was at negative 4, 2. So when I flip it, I end up at 2, -4, but I also need to change that sign on my 2. So my new coordinate for C would be -2, -4. And that would be C prime. Did our points end up in the quadrants that we said they should?
Yeah.
Yes. Okay. So that's your rule for 90 degrees. Now, there are also, if you look at the core concept on page 191, there are also rules for 180 and 270. I am not going to show those to you because I'm not going to tell you that you need to memorize more things. Okay, but if you can memorize the 90 degrees, could you just do it again to get to 180? Yeah. So if I wanted to do C prime and I wanted to go 180, I would take my result, my -2, -4, and I'd go another 90. So I'd flip it, so I'd have -4, -2, and then change the sign. Does that make sense? So at +4, -2, this would have been C double prime if I went 180 degrees. Okay? There are rules, there's a pattern there that you can look at if you want to. Okay? But in the past, students have said that they don't want to memorize all of those. So if they can just do the one and do it twice, they're okay with that. Okay? If you want to talk to me about those other 2 rules, I can sure do that with you individually. Okay? Now I do want to show you one other way that students have told me that they like to do rotations, just so you have some options. Okay, whatever way you want to use is fine by me. I don't really care as long as you can get the right answer. Okay, and essentially what I'm about to show you that students have said they do is the exact same thing we just did. They just in their heads use different words. Okay, so let's say I have this point here. Point A, and that's at -5, -2. Okay. So what they have told me in the past is if it tells me to go 90 degrees, they know it's switching quadrants, right? Okay, so regardless of what the numbers are, I know A prime is going to be in quadrant 4. We all agree with that? Okay. So they tell me, okay, well, I know that I am over 5 and down 2. And I know I need to switch those. So I'm going to go over 2, and then I'm going to go to 5 in quadrant 4. Is it still the same rule? Yes. It's just a different way of thinking about it. Okay, did they still switch their X and Y and change the sign on their front one?
Yes.
Yes, they still did, but instead of thinking about it as that rule, they thought about it as just being over 5 and down 2. I need to switch them. I'm over 2 and then I go to 5 in quadrant 4. Okay? So that's how I've had students in the past show me that they like to do it. Again, if you can use the rule, you're doing that same thing. If you're doing this, you're still using the rule. It doesn't matter how you're doing it. They should both get you to the same answer. Okay? If you have questions when you're working through your assignment, make sure you ask. It's part of the reason why I'm trying to give you a lot of work time is so you can do these in class. Okay. Are these two shapes, these two triangles here, my blue one and my black one, are they congruent to each other?
Yes. Mm-hmm.
What was that word with transformations that meant we preserved their size and shape? Rigid motion. Okay? So if those are congruent, is a rotation a rigid motion?
Yes.
Yes. Okay. So now we have a translation, reflection, and rotation, and they're all rigid motions, right? Okay, meaning they all create congruent figures. Okay, that's your postulate. Example 3 is a composition, and I'm going to skip that example so you can work on these problems on your own. But if you're doing a composition, okay, you're just doing multiple things at the same time, or to your figure, right? Okay. Now we've added in reflection. So maybe you're going to do a translation and then a reflection. Or excuse me, we added in rotations. Maybe you'll do a translation, reflection, reflection rotation, translation rotation, anything like that, any of those combinations. But does it matter what order you do them in?
Yes. Yeah, it does.
Yes. If they tell you to translate it and then rotate it, you need to translate it first and then rotate it. If you rotate it and then translate it, you'll end up in the incorrect place, especially once we start getting to reflections and rotations. Okay, so be careful with those. Do it in the order they ask you to. The last thing I want to talk about before I let you get to work is what is called rotational symmetry. What do you suppose that means, rotational symmetry?
It means that you can rotate it, it will always look this way.
Right, so you can rotate it and it will lie back on top of itself, right? Does this regular hexagon have rotational symmetry?
Yes.
Yeah.
Okay. Now the other catch that always trips students up is rotational symmetry has to be 180 degrees or less. Does that make sense?
Yes.
Where would my green circle be at 180 degrees?
On the bottom.
On the bottom. Okay, so we're going to go through this. We'll figure out how many times it has rotational symmetry, and then we're going to go back and figure out at what degrees does it have rotational symmetry. So how many times do you think it's going to have rotational symmetry at 180 or less?
6.
Or 180 or less. 3.
3. Okay. 1, 2, 3. Right? Now, could I keep going? Yes, but it wouldn't be considered rotational symmetry because rotational symmetry is 180 or less, right? Okay, so it has rotational symmetry 3 times. Okay, but your problem today and on your quiz tomorrow is going to want to know at what degrees does it have rotational symmetry. Okay? How many degrees would be going all the way around? 360. And it would have rotational symmetry 6 times because there's 6 sides, right? Okay. So how do I figure out how many degrees one time is? 360 divided by 6, which gives me 60. So that means if I rotate it 60 degrees, that takes me to my first rotational symmetry. Okay? If I rotate it another 60,
120.
that puts me at another one, but that would be 120 degrees, right? And then my final 60 would be at 180. Okay, so on your quiz tomorrow, if you happen to get a hexagon, you would mark the boxes that have 60 degrees, 120 degrees, and 180. Okay? True or false, it falls back on top of itself at 240 also. True. Are you going to mark that box though?
No.
No, because rotational symmetry is 180 or less. Okay? That's not saying it doesn't fall back on itself at that degree, because it most definitely does. And it does it again at 300 and 360. Okay, but it's 180 or less for rotational symmetry. Okay. I know we went through that fast. Are there any questions before you get started? Okay, if you come across questions in your assignment, make sure you let me know. You have plenty of work time, so you have plenty of time to ask questions. No, I want you to do your test corrections.
No, it's fine.
No.
Just do it tomorrow.